Hello there guys, welcome back to another epic and extra real maths video. In this video, we're taking a look at Taylor series once again, and this time we want to find the first three non-zero terms of the Taylor series expansion of cos 2x about x equals pi over 4. So this is different to the ones that we've done before, because instead of being asked to write it in sigma notation, we've only been asked for the first however many terms. In this question, the first three non-zero terms. So this can be harder or easier, depends. Normally I would say it's easier because you don't need to come up with an algebraic expression for the nth term of the Taylor series. That can sometimes be difficult. You don't have to do it here. We can just write the first three non-zero terms and then say plus dot 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 and we're done. So normally this is easier, I would say, but it's all subjective. The thing is though that links this is we're always going to start the same way. We start by writing the function. The function is cos 2x. And again, it's based around pi over 4, which we'll get to in a moment. Okay, so it's powers of x minus pi over 4. So that's the function. What would be the derivative of this function? Well, it'd be minus 2 sine 2x, okay? And what's the derivative of that? What's the second derivative? Well, that would be minus 4 cos 2x. Okay, what's the third derivative? Oh, just dropped the chalk. What is the third derivative going to be equal to? Well, that would be 8 sine 2x. Fourth derivative? That's going to be 16 cos 2x. And let's just do one more. Fifth derivative. And this would be minus 32 sine 2x. Now, because we're looking for the first three non-zero terms, it's not really very obvious which terms will be non-zero and which ones will be zero. Sometimes. Maybe here it's a little bit clearer. I don't know. Depends how good you know your trig values off by heart. But yes, some of these are going to be zero. You might be saying, why have you done 5 derivatives? There's only 3 terms. Well, a lot of them are going to be zero. That's why we need them. And it looks like we're probably going to need about this many, but sometimes you might have to do a few more in the middle of the question. Who knows? Okay, so what I would do here is I would then evaluate all of these at pi over 4. We need f of pi over 4. We need the derivative at pi over 4 as per the formula, the nth derivative at a. And let's do that. So what is, and by the way, 2 times pi over 4 is pi over 2. So whenever we do these, we can just think of what is cos of pi over 2, what is sine of pi over 2. Cos of pi over 2 is 0. So this is 0. And sine of pi over 2 is 1. So this is minus 2 times 1, minus 2. Okay. Second derivative evaluated at pi over 4. Again, there's a cos, so this is 0. The sine, so it's 1, but it's then times by 8. So that just becomes 8. This becomes 0. Oh. And the last one is minus 32 times 1. Okay, so now we have 5 derivatives, and do notice that 3 of them are non-zero, so those will be it. We probably don't need any other terms. Okay, so I'm going to do a big dividing sign here, and we can actually start writing some of the terms out. So I'll do it down here so I have a longer line. Cos 2x, okay, is going to be equal to, first term, is just the derivative, or sorry, is the original function evaluated at a, and that's it. So just 0. Okay. Next term, again, this is when n is 1 now. So the first derivative evaluated at pi over 4, which we have here, it's minus 2, divided by 1 factorial times x minus pi over 4 to the 1. So it's just going to be minus 2 times x minus pi over 4 to the 1. Okay, cool. All right, the third term is when n is 2. So when n is 2, we have the second derivative evaluated at pi over 4, which is 0. So yes, the whole thing is 0, but it's good to write out. It just helps us. Divided by 2 factorial times x minus pi over 4 to the 2. Okay, what do you think the third, or the fourth term, but when n is 3, what will that be? Well, it's the third derivative, 8, divided by 3 factorial, so 8 over 3 factorial times x minus pi over 4 to the power of 3. Cool. What about when n is 4? Well, again, it's going to be 0, but we should write it out anyway. So we have 0 divided by 4 factorial times x minus pi over 4 to the 4. And I know there's no room there, so we have to come down here. The last term is the fifth derivative evaluated at pi over 4, minus 32, divided by 5 factorial, so minus 32 divided by 5 factorial times x minus pi over 4 to the power of 5. And this keeps going, but we don't need to write out the other terms. Then we just have to simplify it, and that's basically all there is left to do. So how do we simplify? Well, first term is 0, I'm just going to ignore that. The next term is minus 2 times x minus pi over 4. The next term is 0. The next term is 8 over 3 factorial. 3 factorial is 6. 8 divided by 6 is 4 over 3. So plus 4 over 3 times x minus pi over 4 cubed. The next term is 0. And then we have 32 divided by 5 factorial. So 5 factorial is 120. So we have minus 32 divided by 120, and we'll simplify that in a second. And then we times that by x minus pi over 4 to the power of 5. And then again, it's dot, 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 because there's more terms. So 32 over 120, where's the, there it is. 32 over 120, let's do this step by step. Obviously, if you had a calculator, then this would be a piece of cake. But that's the same thing as 16 over 60 by halving both sides. And then we can halve both sides again to get 8 over 30. Half again, 8 over 30 becomes 4 over 15. And 4 and 15 are co-prime. They don't have anything to do with each other. They don't have any common factors. So 4 over 15 is the most simplified version of that. And that's the answer. And again, this is cos 2x. So cos 2x, and we can even say that it's identical, that's absolutely fine, is equal to this series expansion here. As I've said in past videos, especially in the last video, it's really important to know that although I have said that these are identically equal to each other, the function and the Taylor series, this is sometimes only true for particular values of x. So if x is close enough to pi over 4, then they are the same. If x is far away, then sometimes they are still the same, and sometimes they are not. And this is called the radius of convergence, okay? So it's the range of values of x for which the function and the Taylor series of the function are equal. And it's related to when the Taylor series in sigma notation, when it is a convergent sum. If it converges for particular values of x, then that's where the Taylor series is valid. We will look at all of that though in the future, so please don't worry about that now. It's a more advanced topic than just this, so you may not even need to know about it. Okay, I'm thinking about A-level further maths, you don't need to know about it. If you do anything else, then you might. But this is here, so this is it. Cos 2x is this series here, at least those are the first 3 non-zero terms. As always, guys, thank you so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.